Well, yesterday I thought we were going to finish the studio upgrades. We haven't gotten to that just yet, but it will probably be done in another couple of days. And Peter Segovia, our newest supporter. Thank you. Your support is appreciated. Well, it's as clear as a bell out there, and the reason for that is ridging. This is the mid-level wind chart, and here we've got that ridging along the west coast. And since it is a shallow type of ridging, we tend to see a lot of fair weather with that. The high amplitude ridges, usually what that does is it taps into a lot of the cold air up in Canada and sends that south. And that's like a huge shovel that helps produce lift. So with the shallow type of ridging, mostly what we see here is just dry conditions aloft and lee side troughing. So the jet stream patterns are going to look something like this. It is still a split flow, but it is starting to recede north into Canada, and we're left with this main branch running from the Great Basin out to the southern U.S. A lot of the lift is concentrated out ahead of this trough right here, and that's placing the lift in places like Alabama, Tennessee, and Kentucky. And then on the backside, we've got subsidence across much of Texas, Oklahoma, and Kansas. And also right in the middle of the ridge, in the axis, we expect to find subsidence there also. California, Nevada, probably fair skies, and downstream from that, on the right side of the jet also, some good weather is likely. Well, here we've got some rapidly changing weather in the southwestern U.S., and we kind of alluded to this yesterday. You can see there at Tonopah and in Utah, northwest winds, and even there at Tonopah, 34-knot gusts. So that is definitely a new, fresh, cold air mass coming in. And what's interesting is when you look at the WPC charts, the official Weather Prediction Center charts, so that's what they have there at 18Z, and you can see that it extends up through eastern Idaho. But if you look at their forecast, this is 8 p.m. this evening, and they've got it all the way down to the Four Corners area. So how did it move that far in just 6 hours? That's why I think this is the correct solution. I think our front is actually down in that area. In that little nose of enhanced pressure, I think that's probably a sign there of cold air advection working in through that area. Well, the visible satellite loop looking like this. Looks kind of unsettled over the central and northern Rockies. And this is probably a cold air advection pattern setup. Cold over warm. Got that very strong heating in the Great Basin area, contrasting with cold mid and upper level conditions. And that's probably associated with some of that cold air advection back behind the front, which as we showed was kind of in this area right here. Down to the south in the continental tropical sector, nothing at all. Very spring-like in that area. Just lots of heating working on the air mass and very little moisture with that. And out in New Mexico, around the Raton, Las Vegas area up to Trinidad, you can see some of that lee side cirrus. And that's associated with that jet stream that we pointed out that's kind of oriented like that. Typically with this very strong zonal flow, we tend to see that mountain wave activity. There's some of that right there in Colorado. And then the lee side cirrus, which is right there along the Sangre de Cristo Mountains. So on the high plains, we've got quite a bit of cumulus developing. So what can we say about that? Well, as we can see, it is kind of disorganized. We're not really looking at a linear boundary with that. Elements are just forming wherever. Another finding is that it looks a little bit elevated. You can see there's not much of a low cloud field. We're not seeing that stratocumulus like you see out in Missouri. Those are elements that we normally see with deep convection based at the surface. So it's probably combination of a couple different things, probably a lot of strong mid-level lift, and you can see how that cirrus working in through eastern Colorado. It's probably a bit of a trough moving through that area. And then referring back to the surface chart, yeah, the dew points are very low in that area, 20s and 30s. Don't have any return flow from the Gulf. Any moisture that we have is just residual there in the Panhandle region. So this is mostly a lot of mid and upper level lift working through that region. Well, yesterday we had the thunderstorms looking like this. Remember, we had a little cluster of cells up in Oklahoma and then a larger MCS down in East Texas. It's really important to understand the evolution of overnight convection when you forecast. So let's run this forward and look at 24 hours of development. You can see that the stuff around Oklahoma continues surging east towards Memphis and falls apart, and then that southern line moves east into Georgia very quickly, with more developing along the tail end. So now that we have a much better idea where the convection is and where it's come from, let's look at the surface chart. So there you go. You can see the squall lines right there, and they've kind of washed out some of the frontal positions. But we know these squall lines originated from East Texas and kind of moved like that, and that's probably helped to propagate the cold front southeastward. So the frontal patterns will look a little bit like that. And then I think this system up in Tennessee, that's probably going to be an occlusion. So what I'll do is I'll just kind of maybe draw something like that there. So that's kind of my guess of what's happening in Tennessee there. Now here's my tip for you on how to get these 24-hour radar loops. We go to College DuPage. They've got a great radar and satellite interface. What we do is we scroll down, make sure we have composite radar selected, and then we go down to this frame interval. Normally it's set up to show every frame, so it'll be set to all, but what we want to do is set it to every 6 frames. So that'll skip 5 frames, show you a frame, skip 5 frames, show you a frame. So that'll take you 6 times further back in time. And that'll give us a full day. So when we run that, yeah, that starts out yesterday at 21Z. It goes all the way to 2030Z. So that's almost 24 hours. Well, for the northeastern U.S., looks like that onslaught of polar air has finally come to a close. And what we've got is just the air kind of stagnant compared to what we had earlier in the week. It's kind of like taking a cake out and setting it on the stove, and it just sits there. And the air mass is just sitting there, kind of bringing in warmth from below and modifying. And it's starting to edge a little bit westward in advance of this next Alberta Clipper type system coming in from Iowa. And there's the visible satellite imagery showing that a lot of the cloud material is coming from the stuff further down towards the Gulf. And then that other little system going through Iowa barely showing up, so it's probably a little bit more shallow. And in the Pacific Northwest, very showery. Look at all that cumulus just all over Montana, Wyoming, the Dakotas, developing with surface heating. Where's it all coming from? Well, we do have a northwesterly flow, so we're probably seeing some polar air spilling out of Canada and modifying with that very strong surface heating because it's almost May. Bring out any cold air with May insulation, it's going to be very unstable. And another reason, we'll check out the upper level chart. Here's the 300 millibar chart up at the top of the troposphere to 30,000 feet. We have a jet stream running through Oregon, Idaho, and of course that puts Wyoming, Montana kind of in the divergent left front quadrant. So that's probably partly what's happening, and also the lower heights in that area probably co-located with some cold air aloft, which means steep lapse rates. And maybe we can bring up a sounding. Let me click on, let's say around Billings. Can't do that. Well, we'll go to the NAM to do that. Advance this up to 21Z. Now let's back that up. We don't want to be in the full brunt of convection. Let's try 18Z. We'll do a forecast sounding. And there you can see the very steep lapse rates. It's almost dry adiabatic. And you can see the very cold air aloft up there at the top of the column. 300 millibar temperatures, almost minus 50 Celsius. So that is pretty much the story of what's happening in that part of the country. And there's what we have on the surface chart. Looks like we're back in behind this cold front. Cold air mass over Wyoming and the Dakotas. And then we've got this other air mass over Washington, Oregon, Idaho. Things are pretty showery in that area, and I think some of this is due to the influx of cold air coming in from the Pacific. And I figured I would go to the Weather Nerd site and try to dissect this air mass just a little bit. I'm going to set up a cross-section. We're going to draw that from British Columbia down to, we'll say just south of El Paso. So we should intersect that front somewhere along that line. So what do we see here? Well, first let's see where the halfway point is. I'm going to go to this little inset. The halfway point is going to be southwest of Salt Lake City. So this is going to be probably the Salt Lake City area. Well, I do see some slope to the isotropes in this area. This normally would suggest that the cold front is going to be right there. That's probably the cold frontal surface, and that could certainly be the case, so that would place it in southern Utah. I do see a little additional isotrope kind of in here, so a little bit of packing. No, I don't think that's actually the actual front. I think that probably puts the front kind of like that. And you can see the jet stream, the polar front jet right on top of that, which is exactly where it should be located. That's going to be back behind the surface front. There it is. So yeah, I think this would support the front being in southern Utah. And that's one way you can use cross-sections to reinforce the analysis. And just a quick look at Europe. Very, very stagnant pattern. I think I can sort of pick out a frontal boundary there in Germany and the Netherlands, kind of a weak front through France and up to Denmark. North of that, got that continued northerly flow there in the UK. South of that, not much of anything going on. And I'm not even going to go down to the Mediterranean. There's something going on out there in the Eastern Med, but I'm not going to go all the way down there. Let's look at the thickness and pressure. See, that just kind of reinforces how dull things are. The only thickness gradients we see are up in Norway in the North Sea. That's probably supporting that little boundary that I've got south of the UK. Other than that, not much going on at all. Over the next couple days, just run that forward real quick. Yeah, a little frontogenesis coming together there in Germany, but still very quiet. We just kind of push this little front, I guess, down into Hungary. It's kind of an outgoing system going east. So that'll be out of the picture pretty quick, and then the next change looks like that's coming in from the west. Coming into the UK, Scotland, and that should bring a change later in the weekend. And then a quick run through of our forecast for tonight. Pretty much like what you saw in the surface analysis. We've got a little frontogenesis coming together there in the Four Corners area. And that's about it. Our outgoing system there in Georgia and South Carolina should be out of the picture soon. This little squall line that the NAM seems to be verifying well on. Well, we'll see what happens to that. We'll move forward overnight. Squall line falls apart there. I guess it's cut off from the moisture in the Gulf, and things just move eastward. You can see out in the Four Corners area, see that thickness gradient coming together. Pretty impressive. So that's going to be the next change coming in from the west, and you can see how that sinks south into northern Arizona, Albuquerque, Santa Fe. And then for Friday afternoon, Looks like things kind of shift eastward, that little Bear Clinic low moving into northern Texas there. And then by tomorrow evening, that looks to be where the fronts are. Very limited return flow from the Gulf, so we're not going to see much showers or thunderstorm activity. Looks like most of that's going to be concentrated in this area of strong convergence in northeastern Oklahoma. Things will shift eastward overnight. Looks like a lot of this is probably going to be elevated there in Arkansas as it moves eastward overnight tomorrow night. You can see the cold air advection coming in through the backside there into Little Rock, Texarkana, Shreveport, Dallas. So kind of a cool start to the weekend. And then for Saturday evening, that system will be moving into the Ohio River region, the Bear Clinic low itself, moving through the Atlanta area, and not a whole lot of organized convection with that. Back behind it, I know it doesn't really show up very well, but there is high pressure through this area right here in the Great Plains. So that's going to mean cool northerly flow in the central U.S., and on the backside of it, some return flow, a little bit of upslope starting in southwest Texas. And then we can see the thickness line start to pack up once again in California, Oregon. So that kind of draws my attention there. Maybe a bit of frontogenesis starting in this area. And we can see the cold pool, little upper level low, out over the Vancouver area. So it's probably going to be kind of showery in that area Saturday. Going forward overnight, our Bear Clinic system there on the East Coast moves up the Atlantic seaboard. Looks like a little bit of showery weather for Sunday in New York and New England. And you can see the wintry mix in Vermont and New Hampshire, upstate New York. It's hard to believe. It's almost May and we've got snow coming down in Albany and up in that area. Out west, I don't see anything coming together in this Bear Clinic zone. We definitely have the thickness packing, but looks like no good upper air support coming together just yet. So our attention shifts to the west, and we may have a little bit of a warm front there approaching the Oregon coast. And another thing that's implied here, if you look at the general shape of the thickness lines, the red lines indicating ridging. So that's probably what's happening aloft. And that's going to mean pretty warm weather in the Rockies and Arizona, New Mexico. So it's going to start to feel a little bit more like late spring. And out in the eastern U.S., strong cold air advection coming in off the Great Lakes into, you can see that, see down here, the thickness kind of forms a trough. That's going to be the maximum of the cold air advection, so it's going to be kind of cool there in the Carolinas, Tennessee, and Georgia. Okay, I think that's all I've got for this installment, so let me go ahead and start editing and get this uploaded. I appreciate y'all watching the webcast, and we will see you tomorrow. Thanks. Bye-bye.